Welcome to Pomodoro Joe for Friday, September 29th, 2023. Today we're looking at LeetCode problem 896, monotonic array. This is an easy problem. So we have an array that is monotonic. No, we don't. An array is monotonic if it is either monotone increasing or monotone decreasing. This means that it is only increasing as it goes from left to right or start to end, or it's only decreasing in value as it goes from left to right. An array, nums, is monotone increasing for all I less than or equal, okay, blah, blah, blah. Basically, this is just saying monotonic increasing means that you start with a low number and every value is either greater than or equal to the previous value in the array. So you go from left to right, check to see if you have increasing values. That's monotonic increasing. And monotonic decreasing is sort of the opposite. You start with big numbers and every number as you go from left to right has to get progressively smaller or stay the same, less than or equal to. All right, given an integer array nums, return true if the given array is monotonic or false otherwise. All right, so we don't know if they're looking for increasing or decreasing. In fact, they are looking for either increasing or decreasing. We just have to find out if it is monotonic one way or the other. All right, let's put 25 minutes on the Pomodoro timer and we'll get started. So there are a lot of different ways to solve this problem. I think I'll start with the way that I like best, and then we can look at some other options. All right, so for this one, I think I'll keep a state. Now in the beginning, we don't really know if this is increasing or decreasing. It's sort of an unknown state. So here's my state map here. We have three options. We have an unknown state. I'll set its value to 0. We have a decreasing state. I'll set its value to -1, and I'll have an increasing state. And I'll set its value to 1. Now, the values don't actually matter. I just need distinct values so that if I'm in a state, I can check against decreasing, unknown, or increasing. Okay, so the first thing we'll do, if this nums array is fewer than 3 elements, that means if there's just 0, 1, or 2 elements, then we can return true. If there are no elements, it's monotonic. If there's only 1 element, it's also monotonic. If there are 2 elements, even if they're different, they can only be different in increasing or decreasing, so it has to be monotonic. So if the length of our nums is less than 3, then we can return true. All right, so now we have to figure out, is this increasing, decreasing, or just flat the entire time? So the first thing I'll do is just look for some difference between two values. So let's have some index here, and we'll start it at index 1. Now let's see, I'll just say while our index is less than the length of our nums, and while the values at this index, nums at this index, is equal to the nums at the previous index. So I'm going to start at index 1 so I can compare this first index, index 1 to index 0. Then I'll compare index 2 to index 1, index 3 to index 2. All right, as long as these values are the same, then we don't know if this is increasing or decreasing. It's just the same, it's an unknown. So I'll just increase my index by 1 every time until we find two values that are not the same, or we run out of values. All right, if we run out of values, that means all the values in our array are exactly the same. So now at this point, our index is on some value that is distinctly different from the value before it, or we're out of values. We went through the entire array, all the values are the same. In that case, we'll return true. So let's check that first. If our index is equal to the length of our nums, then all the values in our nums are the same, and we'll return true. Now, if the index is not at the end of our array, that means we found two values that are different. So let's check if our nums at this index, that's greater than the nums at the previous index. So if the number at this index is greater than the number that came before it, that must mean we're in the increasing state. All right, I don't actually have my state here, so let's have a state, and we'll set it to unknown. All right, if we get to this point, That means we do know what it is. We're in an increasing state. So our state is increasing. I'm just going to copy this here. And if we're not in an increasing state, then we must be in the decreasing state. And now we have to go through the rest of our array to see if it conforms to the state that we already know we've detected. So for every, let's see, I'll just call it I in range, and we can start at this index. And we will go to, let's see, I guess we can start at index +1 even. And we'll go to the length of our nums. And now we'll check to see if the value at index I and the value at index I minus 1 conform to this state that we've already detected. So let's see, if we're in the increasing state, then we're expecting the value at nums index I to be greater than or equal to the value at nums index I minus 1. So I'll actually look for the opposite of that. We'll look for the case where the value at index I is less than the value at index I minus 1. If that's true, well then we've broken our increasing streak and we have to return false. So if nums at this I is less than nums at I minus 1, that means we suddenly went to a decreasing state and we have to return false. All right, and now here if state is decreasing, we check the opposite. So if the nums at this index happens to be greater than the nums at the previous index, then we just broke the decreasing state and we have to return false. Now if we make it to the very end, we've gone through and checked everything matches the state that we're expecting, well then we can return true. All right, let's try this. All right, seems to work. Let's see if we can pass all the tests. And we pass. And let's see, we do really well actually. We beat 94% for runtime and 95% for memory. Wow, that's better than I expected. Now we could come back here and change a few things. So I'm doing two separate if statements here. Now I could just do an if and else. That might be faster, but branching is tricky. So this actually could end up being slower. We have one less compare, but the branching in this might be a little bit more complicated. Let's see. Looks like it's about the same, but our memory gets worse. So we went from a 94% for runtime to a 96% for runtime, almost a 97% for runtime. But our memory went from a 95% to a 33%. We took a big hit in memory. All right. So that's how you can do this using these states. You figure out what state you're expecting, and then you check to see if all of the other elements conform to that state. So let's see, we could do that, or that's another way we could do this, or a shorter way we could do this. Okay, let's try this. We'll keep the beginning part. If the length is less than 3, we can return true. Instead of keeping a state, let's actually keep two separate variables. One that says, yes, we are increasing, and the other one says, yes, we are decreasing. So we'll have increasing and decreasing. I'll just have increase and decrease. And right now I don't really know, so I'm going to set each one to false. So we're not increasing and we're not decreasing yet. We don't actually know. Okay. Now let's keep track of our previous value. And we'll just start at nums index 0. Okay, so now we can go for every number in range. Actually, we can just go straight to our nums here. For every number in nums, if this number is greater than the previous, well then we must be in an increasing state. So we'll set increase to true. If this number is less than the previous, well then we must be in a decreasing state. So we'll set decrease to true. And if it's the same, we still don't know. If this number and this previous number were the same, we just don't know. All right, and then we do have to set our previous equal to this number so that when we go through this loop, we'll keep checking against the previous value. Now, here's the trick. If we ever detect that we think we're increasing and decreasing, well then something's wrong. We can't be both. So if increasing, or increase, equals true, and decrease equals true, well now something's wrong, so we'll have to return false. Now if we make it all the way to the end, just as we did before, we can return true. And let's see if this works. Okay, it works. Let's see how it does. And we pass, and we do really well. Let's see, we beat, oh, we don't do as well as I thought. We beat 65% for runtime, but 95% for memory. So yeah, we do all right. Now, one thing we could do, we don't actually have to compare this to true. We could just say if increase and decrease. What else could we do? We don't actually have to compare this to the first time. We're doing one extra comparison here, so we could start nums index 1 and go to the end. I don't know if that's going to save us anything really though. And let's try that. All right, that gets us up to a 94% for runtime and an 83% for memory, so also a decent solution. Okay, so there's a lot of different ways you can solve this one, but the basics are this. You need to sort of keep track of what state you're expecting. What do you think we are doing? So in this case, when we get our n greater than our previous, we think we're increasing, so we'll set that to true. In the previous solution, we actually looked at explicit states. We tried to find the state initially. Once we found the state, then we compared all the other values to see if we match the state we're expecting. So in both cases, we're keeping some type of state and we're checking the rest of the array against our expectation of that state. All right, I recommend you try this one. This one's super fun. It's pretty easy. So yeah, go give it a shot. Okay, well that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.